Hello everyone. Today we will find the mean of chi-square distribution. And we know that for finding any chi-square distribution or finding any distribution's mean, we simply have to take the expectation of that. Expectation of that distribution's random variable. First of all, this chi-square distribution has a PDF. Chi-square, which is defined as 1 by 2 to the power n by 2 divided by n by gamma n by 2 e to the power minus chi square divided by 2 chi square n by 2 minus 1. This is the PDF of chi-square distribution, and as I already mentioned, for finding any distribution's mean, we simply have to take the expectation of the random variable of that distribution. Here the random variable is chi-square, so we take the chi-square's expectation, and for as it is a continuous distribution, so we have to take integration from minus infinity to plus infinity. So and we have to put the variable inside the expectation, chi-square, and we have to put the chi-square's distribution. Here the chi-square PDF is this one, so we have to write f of chi-square d chi-square. So that is it. This is the expected value looks like, and we will extract this one. Minus infinity to 0 chi-square f of chi-square d chi-square plus 0 to chi-square 0 to infinity chi-square f of chi-square d chi-square. Now if you look at that, this part will create value 0. Why? Because this PDF is generally defined for 0 from 0 chi-square to plus infinity. So 0 to infinity, this PDF is valid, but beyond less than 0 it is not valid. So it will be there is no equation exist less than 0, so it will create a value 0. So we will remain with this part only. So we have 0 to infinity chi-square f of chi-square d chi-square, and if you put the value 0 to infinity chi-square, PDF is defined already here, 1 by 2 to the power n by 2 n gamma n by 2 e to the power minus chi-square divided by 2 chi-square n by 2 minus 1 d chi-square. All right, and next what we can write, okay, see this is a constant part, right? So we can take it outside of the integration, 1 by 2 to the power n by 2 0 to infinity chi-square e to the power chi-square by 2 chi-square to the power n by 2 minus 1 d chi-square. Now if you look, this is a chi-square with power 1, this is also a chi-square with power this one, so this power will be addition. So we can write 2 to the power n by 2 0 to infinity. If this power 1 adds up here, this one and this one will be cancelled, so we will remain with e to the power minus chi square by 2 chi square to the power n by 2 d chi square only. Okay, now here the complex part is chi square by 2. So why not let chi square by 2 is equal to z, or some variable z. Basically what I'm trying to do here, we want to transpose this chi square to some sort of a new variable with a new functionalities that will be more easier than solving this integration. So what we can write here, chi square is equal to 2z. So as I am going to transpose chi square into z, some variable, I have to derivative both side with dz, d by dz of chi square and d by dz of 2z. So I differentiate this part and differentiate this part with this d by dz. What I will remain with? I will remain with d chi square divided by dz. If you differentiate this, you will find only z, and you can write d chi square is equal to sorry, if you differentiate that, you will find 2, and d chi square you will find with d2 dz. That's what you will find. Now there is a part from here. What we can write, we are now at the our main part, and it is 1 by 2 to the power n by 2 n by 2 gamma n by 2 0 to infinity e to the power, this part we assume z, so minus z, and this part we assume 2z, so it will be 2z to the power n by 2, and d chi square is 2 dz. Now what we can write, 1 by 2 n by 2 n by 2 gamma. So if you see, we can extract this part, right? How? 0 to infinity e to the power minus z. If we extract this, we will find two parts, 2 to the power n by 2 into z to the power n by 2 into 2 dz. All right, and from here, if you notice, this part is a constant in terms of dz. This 2 also constant, so it can be outside of this. So we can write 2 into 2 to the power n by 2, 2 to the power n by 2 at the denominator, n by gamma n by 2, integration 0 to infinity e to the power minus z, and z to the power n by 2. If I add a plus here, plus 1 here, and a minus 1 here, is that any problem? The reason why I'm doing this, I will tell you at the very next line. So here is a dz as well. So if you notice that this part and this part can be cancelled, so I'm leaving with 2 to the power 2 divided by gamma n by 2. And if you look at this part, okay, now there is an important part. If you integrate 0 to infinity to e to the power minus x, x to the power n minus 1, then it will be gamma n divided by a to the power n. So if we compare this one with this integration, you will find that n is nothing but this part, right? N by 2 plus 1. This is for this equation, the second equation. This is for the first, that the main one. Okay, and here a is 1. So if we put the values here, what we will find, see, from here what we can write, 2 to the 2 divided by gamma n by 2, and this integration will give me gamma n by 2 plus 1 divided by 1 to the power n by 2 plus 1. Right? So what I'm leaving with, this is will be 1, so I'm leaving with n by 2 into gamma n by 2 plus 1. And if you extract this part, you can write it 2 n by 2 gamma n by 2 divided by n by 2. And how this happens, basically because n plus 1 is gamma n plus 1 is equal to n gamma n. So ultimately what we will find with cancelling this one to this one, and this 2 will cancel this 2, then we will live with n. So that is our expectation of chi-square. So it is actually the mean of chi-square distribution. Thank you very much.